Molecule Theaters presents covalent and polyatomic molecules in Lewis dot diagrams. Da, 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 da. This first molecule that we will deal with is C3H8. This molecule, commonly known as propane, is a covalent molecule with 3 carbons and 8 hydrogens. As you can see on the periodic table, hydrogen has 1 valence electron and carbon has 4. The first step to creating the Lewis dot structure of our molecule is to create the Lewis dot diagrams of each individual element atom that's in it. This one is made up of carbon and hydrogen, and carbon has 4 valence electrons, which is why it is shown as a big C with 4 dots surrounding it, and hydrogen has 1 valence electron, which is why it's shown as an H with 1 dot above it. And there are 8 of those H's to represent the 8 hydrogen atoms, and there are 3 C's to represent the 3 carbon atoms. When you add all these electrons together, you get a total of 20 valence electrons, and when you divide them by 2, you have a total of 10. Since there are no previously paired electrons, you don't subtract anything from the 10, giving you a total of 10 bonds in your final Lewis dot structure for your molecule. So this is what your diagram will look like at first. You have the 1 hydrogen valence electron coming to pair up with the 1 carbon electrons that are on the edges, and 1 carbon electron from each carbon pairs up with each other. So that's why there are those 2 bonds in the middle. The next step is to see if this molecule satisfies the rule of octet. So this carbon atom has 2, 4, 6, 8 electrons surrounding it, which makes it stable. And each of these atoms all follow that same thing, so they're all stable. The hydrogen atoms only have 2, but they are the exception to the rule. They only need 2 valence electrons to become stable. So this whole thing does work, and it does stabilize the whole molecule. When it's abbreviated, every 2 electrons get abbreviated as a line, so your final structure would look like this. Yes, we did our first one. We're good to go halfway. So let's move on to the next one. This molecule, PO4 -3 charge, is another molecule that is held together by covalent bonds, but it is a polyatomic molecule, which means it's made up of another two kinds of atoms. And it also has a charge, so it is a -3 charge, making it an anion. This molecule has 1 phosphorus atom and 4 oxygen atoms, and it does take 3 electrons from the atmosphere that are just floating around, and those are all -1 charges, and so that is why this molecule has a -3 charge. If we look at the table of elements, phosphorus over here has 5 valence electrons, and oxygen has 6. So we're going to do the same thing that we did with our first molecule. We're going to make the Lewis dot structures of the atoms. Since phosphorus has 5 valence electrons, it is seen as a P with 5 dots that surround it. And the oxygens have 6, so they are O's with 6 valence electrons around them. When you add all of those electrons together, you get a total of 29, and if you divide them by 2, that is a total of 14.5. And we do have 1, 2, 3, 4, 5, 6, 7, 8, 9 pre-paired electrons, and so we're going to subtract 9 from 14.5, and that gives us a total of 5 whole bonds. There is an extra 0.5, but we're just focusing on the whole numbers. So your final structure is going to have 5 bonds. So this is what it looks like unabbreviated. We have our phosphorus in the middle because it has the most availability for bonding, and we have our 4 oxygens surrounding it. Now this phosphorus atom had 2 pre-paired electrons right there, so the 1 electron that was going to be there gets pushed up here and it pairs with its other missing friend that these two have. So the 1 electron from the oxygens pairs with the 1 missing electron from the phosphorus, and they all pair up. This phosphorus has 8 electrons, so it is satisfied, it is stable. This oxygen also has 8 electrons, so it is stable, but these 3 are all missing 1 electron. And what we're gonna do is we're gonna take 3 electrons from the atmosphere and make them stable. So here's what our structure looks like now. We have added the 3 atmospheric electrons, making this oxygen stable with 8 valence electrons, and all 3 of them follow suit. So your final structure is going to look like this, with these pairs abbreviated. And since the math we did earlier called for 5 bonds, one of the bonded pairs from here is gonna run up and join this one. So we have 1, 2, 3, 4, 5 bonds total. And you put the brackets to let everyone know that this is an ion and it has this -3 charge, which again comes from the addition of these 3 negative electrons. And that's the end! Congratulations! You have reached the end of this video. Hopefully you weren't too bored. Even if you were, I'm sorry, but you're a little bit smarter now, so you're welcome.